Hey devs, this is coding in a nutshell. So Xcode 13, let's have a look at it and do some comparison between Xcode with UIKit versus Xcode 13 using SwiftUI. As of this video, we are now in iOS 15, and Xcode 13 I suppose is widely used by now. I've been using it since its release back in October. I think it has gone a long way. There are a lot of new things to learn that comes out every year, and it's always been a challenge to keep up. So, Xcode is the IDE for developing in Swift. I will go through building a simple app, and I'll be creating a new project. I will write and navigate through the source code editor, run the app in the simulator, and I will be doing both in UIKit with Storyboard and in SwiftUI. When launching Xcode, straight away noticeable is the app icon, which is improved with the hammer in space gray, or what appears to be the hammer in dark mode. Well, dark mode has been a big addition in Xcode. Before, there is only a dark mode on the source editor. Now it's the true dark mode. This is the welcome screen, which can be disabled at launch. There are quick shortcuts like creating a new project, opening an existing project, or cloning an existing project. These are the most common actions when starting Xcode. Before, it also has a starting playground option as the very first option. Maybe not many developers start with that, so that's now removed from the welcome screen. When starting a new project, there are starting templates that are available. There are templates for iOS, watchOS, tvOS, and multi-platform. Back then, it was called cross-platform. For iOS in the past, there were starter templates available from the simplest single-view app or the more complex master detail, page-based app, tabbed app. There were a few more templates than there is now, which is just app. There is still the option at the moment whether to use SwiftUI or UIKit with Storyboard. And if I choose Storyboard, I can even code using Objective-C. But why I would still do that? Well, it's up to you if you have a need for it, but just know that it's there. Let's now have a look at the anatomy of Xcode. At the center is where the activity happens, the source code editor. Obviously, this is where we write code. There are various types of editors depending on what I'm doing. I can edit the storyboard here, or if I select the project, then I can edit with the project editor, where I can customize project settings, build settings, libraries, frameworks, and many others. Here on the left side is where I can select things I want to work on. This is called the Navigator. Here, I will have access to all the files and contents of the project. There are also various kinds of Navigator views that can be selected in the Navigator selector bar. I have the Project Navigator where I can manage all the files in the project. When the project gets really big, we will need some kind of organization like creating folder groups and manage the files so that we can easily find things. There is the Source Control Navigator. This is for GitHub if you are using one. The Symbol Navigator to easily go to specific part of a source code. The Find Navigator, well, to search for specific text. The Issue Navigator that shows warnings and errors in the project. The Test, Debug, and Breakpoint Navigators, which can be used to organize testing points. I haven't used this much. And finally, the Report Navigator. Maybe we can explore these features sometime. Here on the right is the inspector. The inspector provides more context of the file being worked on the editor. Similar to the editor and navigator, the inspector also has different kinds of views. There is the file inspector that shows file names and types, file paths. There is also the history inspector. I think this is again for GitHub to show change history. The quick help inspector that shows help information on what is selected on the editor. Accessibility inspector. I haven't used this much. And the last one, which is the most common one I use, the attributes inspector. Let's talk about the canvas. Now when I am building the UI for the app, it is convenient to have the canvas side by side with code to show an interactive preview of what the UI will look like. Before, when there was no canvas, I have to run the code in the simulator to see how the app is going to look like. And it takes a lot of time. The code will compile, then the simulator will open, it will update or install the app, then run the app. It will take long, depending on the size of the app or the code changes that was made. And if I am doing this iteration frustration of writing code and testing in simulator several times, it is not a very good workflow and consumes a lot of time. It was okay with UIKit when I design using storyboards. At least most of the time, I have an idea where the UI objects are positioned, but this alone is not enough, and I still have to run again in the simulator to see how the UI objects will behave in relation to its container, to its super view, in relation to other objects, or how it will appear in different orientation like in landscape or portrait. With Canvas, there is no second guessing. What I see in the canvas is what I will see when I run the simulator. This saves a lot of time to my workflow. To show the canvas, I can select the Editor menu and click Canvas, or towards the right of the tab bar, I can adjust Editor and select Canvas. The nice thing about Canvas is it is just a SwiftUI code, which is this preview provider. Here, it is just showing the content view. There is actually a return statement, but it is not required, as it is inferred that this is returning some view. And content view is some view. We'll hear a lot about type inference in Swift. So the canvas is just showing the content view. Now, the canvas will only show if there is this preview provider. Otherwise, the canvas will not show. Sometimes, if there is a large update, the canvas will pause, and I have to click the resume button. This top part here is the toolbar. Clicking this app name, I get this manage scheme. I haven't used this before as well, something I have to explore in the future. The simulator device that will be used to run the app can be selected here in the run destination. Its location has changed. It used to be beside the play button, which I can click to build and run the app in the simulator. And then the stop button appears. This will terminate the execution of the app. It is great to see that the stop button disappears when the app isn't running. It used to be there all the time. On the right is where the status of the execution is shown, whether it's building, launching the app, running, or finished. I can also attach an actual iPhone and select that in the run destination and run the app in the actual device. All these sections can be hidden or shown depending on how I am working. For example, if I don't have a need for the canvas, I can hide it, and then I will have a bigger real estate for coding. Let's now create a new project. I can select it from the welcome screen or from the file menu, select file, then new project. Then I will select iOS as the platform, then use the simple app template, then click next. For product name, I will name it card game. So space or no space, it doesn't matter now. It can always be changed later if I change my mind and I want the app name to have a space. For now, I will not include space. For the team, I already created one. For organization identifier, normally this will be my name if I'm working solo, or the team name or company name. It is like a reverse DNS. You know DNS ends with .com. This one starts with com. Then my name or company name. And the bundle identifier is autofilled with a combination of the organization identifier plus the product name. The only requirement is for this to be unique. For the interface, I will select SwiftUI, and for the language, of course, I will be using Swift. Then I will have to specify the location to save the project. Normally, I would create a developer folder under Documents and save all my projects there. Then click Create to complete the project creation. This is now the project, and right here straight away, it can be run in the simulator. For example, I can run it on the new iPhone 13 simulator. I'll just have to change the run destination to iPhone 13 and click the play button to run. The simulator is somewhat similar to the actual device. It hasn't changed much from what it was before. It's just the menu and the location of the items is now arranged and grouped logically. There is now a menu called I/O, whereas before they're all just under hardware. And there are also some new improvements to the workflow. There is this toolbar that has some quick shortcuts, such as this full screen mode. And of course, the simulator. It is way faster now. Let's go to Home. So the simulator will have most of the settings that is essential to a developer. Here I can see my card game app, but there is no app icon at the moment as I did not provide one yet. There's the calendar, photos, maps, settings. In the settings, let's go to General, About. Here it shows that the iOS is version 15. I can also log into Apple ID. There is this developer that can set the device to dark mode, so I can test it in dark mode. Another section that I did not talk about yet is the debug area. It's here at the bottom. This is where I can generate some output from the program when I am troubleshooting or debugging. Let's write some code in SwiftUI. I will be adding an image of a playing card. I will drag the Queen of Hearts into the assets catalog. So I have two of these. The other one has this weird name @2x. When I drop it into the assets catalog, it creates two versions of the Queen of Hearts, 1x and 2x. The 2x PNG actually has a higher resolution. So when there is a higher resolution image available, depending on which device your app is running, the appropriate image will be used. For example, in a Retina display device, the code will load the 2x image. It happens automatically. It doesn't have to be specified in the code. Now, these images are for universal device. If I have an artist in my team and I want a different image for different devices, I can have those images in the asset catalog. I can right-click and select iPhone, for example, or a Mac. Now that I have the Queen of Hearts image, there are several ways I can add it to the app. First one is to select it from this plus sign, which is the object library. Then I go to Images and I can see the Queen of Hearts. I can drag it into the source editor, or I can drag it into the canvas. I can follow these blue lines as guides on where I want to position the image: top, bottom, left, or right. When I drag that, the code is automatically written for me. Because I dropped it on the top of the text, it created a vertical stack, and inside it are the image and the text. These stacks are what we call container views. Another way is command-click on the view, this text view, and this will show a list of actions. I can select Embed in VStack. Now I can drag and drop the image from the object library into the source editor. Let's open up the inspector. With SwiftUI, Xcode always keeps the source editor, canvas, and the inspector in sync. What I mean is, if I select on the line that has the image, similarly in Canvas, the image gets selected. There is this blue line that indicates what is currently selected, and the Attributes Inspector also shows the relevant attributes for the image. Same thing, if I select the Hello World text in the canvas, the source editor highlights the code, the inspector shows the attributes of the text. I can even change the text here in the Attributes Inspector to be Queen of Hearts, and it changes in the canvas and the source editor. By the way, the inspector can also be shown via Control Option click on the view. This can be done either in the source editor as well as on the canvas. The good thing about SwiftUI, even though I don't know what the syntax is, I get to learn them as I build the UI by drag and dropping these objects and letting Xcode write the code for me. Let's talk about modifiers. In the object library is where we can see the different SwiftUI views that can be used. In the example, I already used image and text. In this library, we can also see the different media assets. In the example, I used the card image. There is another tab here called Modifiers. These are SwiftUI methods that customize the way the views look or behave. Although they are methods, they appear here in the object library and can be applied to the applicable SwiftUI views by drag and drop as well. And the code is written automatically. Again, I don't have to know the code syntax, and I learn them as I go. Let's try foreground color modifier. Like the SwiftUI views, modifiers can be drag and drop into the source editor or the canvas. As I've mentioned earlier, the canvas, source code, and the inspector are always in sync. So if I change the foreground color to red, for example, I can change it in the canvas, or I can also write it in code or use the inspector. Let's change gear for a moment and let's try the same thing we did here in SwiftUI using Storyboard and UIKit. Let's create a new project. For interface, I will use Storyboard, so there is no canvas. What we have instead is the storyboard called main. When I select the main storyboard from the project navigator, the editor in the middle opens up with the interface builder. The interface builder used to be a separate application. The interface builder was used for design and Xcode was used for coding. But in Xcode version 4, I think, is where the interface builder was integrated into Xcode. In the interface builder, there are two areas. There is the doc on the left, which lists the object used in the canvas. The document outline of the doc shows a hierarchy of how the objects are nested within higher level objects. This is the canvas on the right. The canvas is where these objects are laid out, and I can drag these objects and position them to where I want it to be. The arrow pointing to the view controller indicates that this is the initial view controller. On the right is a mini-map, which will make it easier to navigate the canvas when the storyboard gets very big and complex. I will not be showing you in detail how to make complex storyboard. Let's save that for another time. Let's get some objects from the library and into the storyboard. Now the library is calling it objects and not views, like the one in SwiftUI. I'll use this label and drop it in the center, following the blue lines as guide. Straight away, there is a warning. I'll go to the issue navigator and read what it says. Views without any layout constraints may clip their content or overlap other views. That is because Xcode doesn't know how to position this label. Although I followed the blue lines earlier, if I build my app UI using Storyboard, it requires that I define how each of the objects get positioned in relation to its superview or in relation to other objects. Now, this is just a warning. I can still run the app. Let's have a look at what happens. Okay, the text shows, but not really at the center. To change the text, I can double-click it or go to the inspector. And after changing the text, it's no longer at the center, and I have to reposition it again by following the blue lines. But it doesn't work anyway. It's not really at the center, as I have not instructed it yet to be in the center. So let's do that. Let's make it horizontally and vertically centered in the container. Now the blue lines are permanent. These are what we call layout constraints. These are the instructions on how to position the label. Now I'll add an image. Similar to what I did earlier in SwiftUI, I will grab this image asset and drop it in Assets. Then from the object library, I can see the image and add it into the main storyboard. Okay, so now there are no blue lines to guide me where I can drop this image in relation to the Hello World label. I'll just drop it on top and maybe put it somewhere in the middle. Let's run in the simulator and see how it looks like. Well, as expected, Xcode doesn't know where to put it. Without the layout constraints, this will not appear correctly as I want it to be. Probably there's a V-stack here. So in the object library, we have a vertical stack view. So let's use that. Just know that this vertical stack view in UIKit is different from the V-stack in SwiftUI. Although it's kind of the same that I drag and drop them from the object library. It's very hard to see where the stack view is now in the view controller. There are a few different tricks that developers usually do here. They would change the background color. I can do that by going to the document outline to select the vertical stack view, then change the background. Now, I can drag the card image and the Hello World label into the vertical stack view. I can do that in the storyboard, or I can do it in the document outline too. Let's run it in the simulator. Now, the vertical stack view shows on top left because I haven't added constraints or instructions to where to position the vertical stack view. Let's do that. I can put layout constraints to the vertical stack view to center it in the view controller. Sometimes it's hard to select the correct object, so the document outline is very handy with this. Now, it's vertically and horizontally centered. Let's run it again in the simulator. Now it looks good. Imagine if I add another UI, then I have to redo these constraints again. Now, it's like magic that I have not written any code, yet I have a running app. Well, there is an XML code written behind the scene for the storyboard, but it's not something that can be modified. If I want to modify an object in the storyboard, I can do that by creating an outlet. To do that, I have to open the assistant so that the storyboard and the view controller associated with it are side by side each other. Suppose I want to change the label programmatically. I will create an outlet. I can control drag from the label here in storyboard to the view controller class. I can also do that from the document outline to the view controller class. When I drop it, I will have the option to name the variable for this label. I will name it card label. Now that I have this card label, which is the representation of the label in the storyboard, I can now change its text to be Queen of Hearts. Let's run it in the simulator again to test it. There are a few more things in the source editor. The source code will have line numbers, and here on the right side, there is this mini map of the source code which shows the miniature view of the file being shown in the editor. And this is very handy when the source code is very long and I can skip to specific area of the code. That's it for this video, and I hope you picked up something useful. And if you do, please hit the like button. And you can also subscribe if you want to. See you in the next one. Happy coding!